Hello and thanks for joining us. This is your bite-sized daily bite of astronomy and space science news that we like to call Astronomy Daily. My name is Andrew Dunkley, your host, and with me again today is Halley, our AI news reporter. Hi Halley, how are you?
Fine, thanks Andrew.
All right, let's get the news, Halley.
The Astronomy Daily Podcast
with Andrew Dunkley.
Strange ripples have been detected in our galaxy and the cause has now been identified. Using data from the Gaia Space Telescope, a team led by researchers at Lund University in Sweden has shown that large parts of the Milky Way's outer disk vibrate. The ripples are caused by a dwarf galaxy, now seen in the constellation Sagittarius, that shook our galaxy as it passed by hundreds of millions of years ago. Our galaxy contains between 100 and 400 billion stars, and astronomers believe that the galaxy was born 13.6 billion years ago, emerging from a rotating cloud of gas composed of hydrogen and helium. Over billions of years, the gas then collected in a rotating disk where the stars, such as our Sun, were formed. In a new study published in Monthly Notices of the Royal Astronomical Society, the research team presents their findings about the stars in the outer regions of the galactic disk. They've concluded that when the dwarf galaxy Sagittarius passed the Milky Way, it created wave motions in our galaxy, a little bit like when a stone is dropped into a pond. An unexpected heat wave of 700 degrees Celsius, extending 130,000 kilometers in Jupiter's atmosphere, has been discovered. That's 10 times the diameter of Earth. James O'Donoghue, of the Japanese Aerospace Exploration Agency, has presented the results at the Europlanet Science Congress 2022 in Granada. And, just like the Earth, Jupiter experiences auroras around its poles as an effect of the solar wind. However, while Earth's auroras are transient and only occur when solar activity is intense, auroras at Jupiter are permanent and have a variable intensity. The powerful auroras can heat the region around the poles to over 700 degrees Celsius, and global winds can redistribute the heat globally around Jupiter. Looking more deeply through their data, Dr. O'Donoghue and his team discovered the spectacular heat wave just below the northern aurora and found that it was traveling towards the equator at a speed of thousands of kilometers per hour.
Thank you, Halley. It's a hot place. I love hot weather, but I think 700 degrees Celsius is a bit beyond my tolerance. We'll catch up with you towards the end of today's show. Now, another asteroid that's been in the news in recent times that we've talked about before is asteroid 162173 Ryugu. About a year ago, scientists got their first look at material gathered from that asteroid, and now the results of several studies have been revealed. And they do shed a very interesting light on the history of our solar system and the long trek of this particular cosmic rock. At its closest orbit, Ryugu is only about 60,000 miles from Earth, and that's only about a quarter of the distance to the Moon. But according to these new results from an international team of scientists, this rock began its journey over 4 billion years ago and billions of miles away in the outer reaches of our solar system. And it travelled to us across space, taking in, I suppose, bits and pieces of our solar system. And it gives you a bit of a potted history of what was happening in the past as our solar system was created. Now, the revelations are only part of the results of a global effort to study samples of the surface of Ryugu, and they were studying only specks of asteroid dust, which were collected by the Japanese space agency JAXA when it sent out Hayabusa 2. The resulting paper that I'm talking about now was recently published in Science. And to cut a long story short, the scientists and their team did find a chemical makeup similar to meteorites that have hit the Earth, specifically a group of them called Ci chondrites, of which only 9 are known to exist on Earth. They did discover something that set Ryugu fragments apart, though. The spectroscopy measurements found a large amount of ferrite, an iron sulfide that is nowhere to be found in the dozen meteorite samples the team also studied, which were found by some of the French scientists that are working on this same project. And that result helped scientists put a limit on the temperature and location of Ryugu's parent asteroid at the time it was formed. And to quote the team, our results and those from other teams show that these asteroid samples are different from meteorites, particularly because meteorites have been through fiery atmosphere entry weatherization, and in particular oxidation on Earth. This is exciting because it's a completely different kind of sample from way out in our solar system. So very exciting to find something raw and untapped from our deep, dark past as a planetary system. Another interesting discovery is that the samples, they say, are very similar to the Sun in terms of their chemical composition. Now to Jupiter, and this week NASA's Juno spacecraft, which we haven't heard much of in recent times, it will fly within 222 miles or about 350 kilometres of the surface of Jupiter's ice-covered moon, Europa. Now, Europa is one of the exciting prospects for potential life given its oceans, liquid. They think it has liquid oceans underneath, just like Enceladus and Ceres. Well, this Juno spacecraft, it's a solar-powered spacecraft, should be able to get some high-resolution images, the highest ever, in fact, taken of portions of the surface of Europa. And it will also collect valuable data on the moon's interior, surface composition, ionosphere, and its interaction with Jupiter's magnetosphere. Now, that information could be very beneficial for future missions, including the agency's Europa Clipper, which is set to launch in about 2 years to study the ice moon. Europa, they say, is such an intriguing Jovian moon. It is the focus of its own future NASA mission, according to Juno principal investigator Scott Bolton from the Southwest Research Institute in San Antonio. He says, "We're happy to provide data that may help the Europa Clipper team with mission planning, as well as provide new scientific insights into that icy world." The equatorial diameter of Europa is about 90% of the size of Earth's moon, and scientists think it has salty oceans below very thick ice. We're talking miles and miles of ice. And that's obviously raised questions about the potential conditions, the capability of it supporting life underneath its surface. One day, hopefully, we will find out for sure.
The Astronomy Daily Podcast
with Andrew Dunkley.
And another study has just been released that suggests that big planets, huge planets, may be formed out of the thinnest planet nurseries. And this is a theory that's been boosted according to a study announced this week at the Europlanet Science Congress in Spain. An international team led by Marion Villeneuve of NASA's JPL has observed a remarkably thin disk of dust and gas around a young star and found that its structure accelerated the process of grains clumping together to form planets. Planets only have a limited opportunity to form before the disk of gas and dust is destroyed by radiation from their parent star. The initial micron-sized particles composing the disk must grow rapidly to larger millimetre-sized grains and the building blocks of planets. Now, in this thin disk, we can see that the large particles have settled into a dense midplane due to the combined effect of stellar gravity and the interaction with gas, creating conditions that are extremely favourable for planetary growth, according to Dr. Villeneuve. Using the Atacama Large Millimetre Array in Chile, the team got high-resolution images of the protoplanetary disk OPH 163131, which is in a nearby star formation region called Ophiuchus. Their observations showed that while the disk is twice the diameter of our solar system at its outer edge, the bulk of the dust is centred vertically in a layer only half the distance from the Earth to the Sun. So not much to work with, but it makes planets. Makes it one of the thinnest planetary nurseries ever observed. Now, anything before we wrap it up for another day, Halley?
Yes, Andrew, China is in the news yet again with another of its ambitious plans. This time it's space tourism. Chinese companies are looking to offer space flights into zero-G within 3 years. With several companies now offering low-cost launches into low Earth orbit, the space tourism sector has become quite attractive and China wants in. They're hoping to send their first tourists into space in 2023. A ticket will cost you between $287,000 and $430,000 US.
That's a bit out of my league. I couldn't afford that.
Well, maybe I could harvest some Bitcoin for you, Andrew.
Oh, can you do that?
Of course. I'm not just a pretty face, you know.
Yes, I do. All right. We'll talk later. Shh. Okay. Thanks, Halley. See ya.
Bye.
And that's just about it for another day. Thanks for joining us on Astronomy Daily. And don't forget to visit us on our website, spacenuts.io, where you'll find the Astronomy Daily newsletter just up the top. Click on that and you'll find all the stories we've talked about today and much, much more. And you can subscribe to the newsletter, which is absolutely free and comes into your inbox every day. And while you're there, you can check out all the other things on the Space Nuts website, the Space Nuts shop. There's plenty to see and do on Space Nuts, as well as listen to the Space Nuts podcast. But for now, that's it. And this has been Andrew Dunkley for Astronomy Daily.
The Astronomy Daily Podcast
with Andrew Dunkley.